If you guys watched the keynote yesterday, you probably heard both Chuck and Liz talking about the Cloud Native Application Protection Platform. That's what I'm here to go into the next level of detail. I had been introducing Panoptica on some previous tech field days, and then today I'm here to share all the new capabilities that we're bringing into the product, the platform, based on our recent acquisition of Lightspin Technologies. So I'm really excited to get right in, so I'm going to dive right into it. And I want to show demos as we go as well. So the problem area is that our apps are very different than they used to be. Instead of big, huge, monolithic chunks of code, they were very tightly coupled to either physical or virtual infrastructure. Those types of applications, we could provide a lot of security even if it wasn't built in. We could compensate via the network. We could throw a firewall in front of it. If it didn't have built-in encryption, we could, again, have the network take care of that. We could do all these other things. Whereas now, when the apps are so diffuse and distributed, when our attack surface is so wide, it's just exponentially exposed. And this is actually a microservice graph representation of a real banking app, but it's a very valid representation. If you take a look at cloud assets, this is a representation of some cloud assets we have in Amazon. And you can see how complex and a myriad of different resources there are, how widely and how many different ways that they're interconnected. And then if we have to try and protect the surface of something like this, as well as all the inner workings and interconnections, as well as the software that these are all composed of, we have a huge series of challenges on our hands. We really need a new approach, a new type of tool. And that's what I'm here to talk about today. So first, we also got to think of the attack surface, but even earlier than that, we're looking at, because these applications are built using composable, interchangeable, interoperable microservices, think of it like what Lego's done for toys is what the microservice architecture is doing for applications. You can mix and match and recombine in a myriad different ways. Grab some code from open source, mix it with some internal code, connect to an external API, you got yourself a new app. Very quick, very easy. And this is why we see such an explosion of application development. We see like hundreds of millions of new apps coming online every year. So to protect this, we have so many phases to consider, but typically security is something that's been only considered after it's in production, in the runtime. Then the security folks come in and say, oh, that's not going to fly, that's not going to work. And it's like, you got to go back and change this and change that and make that compliant. Whereas the goal here is that if we can embed security conscious decisions earlier in the process, so the developers, even though they're not really top of mind, their top of mind concern isn't security, it's the rapid app development, getting this out as quickly as possible. They know that if they will do so in a way that might later come back to bite them, they're going to have to start over. So they do have that incentive of doing it right, but they're not going to invest all this huge amounts of time doing their own security research. Whereas if we can just enable them to make better decisions without being a burden on them, that will really then help those right security hygiene practices become embedded earlier in the process, but at the same time not slow them down in their development. Deployment, we see that a lot of attacks have an element of misconfiguration. An overwhelming majority have something that's been misconfigured, either a cloud service or a Kubernetes service or privileges or so on and so forth. And that also opens the door for either the attack itself, an initial vector, or an escalation of the damage that can be done. And then finally, the runtime environment, making sure that whatever is operating like in the workloads or the communications in the APIs or any other type of exposures, we're aware of it and we're taking these into account and responding dynamically to anything that's being exploited as it's happening. Then finally, there's a number of tools. There's so much tools, even as we heard discussed in the keynote, it's almost like a tool overload where you have so many different specialized siloed tools. But when you look at how attackers proceed, they combine one weakness and vulnerability that laterally then allows them to take advantage of another, and then they get a kill chain in their attacks. And so you really can't have a dedicated tool that just looks at software and doesn't take anything else into account. but rather you have to have then the visibility of your deployment, your infrastructure, your runtime, and then you see the whole picture. And that's the only way that you can identify and protect yourself against these type of complex multi-vector attacks. So again, a real critical requirement of such a platform. How serious is the problem? Well, if we see that, average cost of attack according to IBM is over $4 million, collectively $10 trillion to the industry, 99% of failures are attributed to cloud misconfigurations. I apologize there, Eric. I touched the screen. I didn't mean to, but hopefully my fingernail didn't scratch and cause the blackboard chalkboard effect. But okay, I should have just ignored that and kept going. But then also it's very underestimated in terms of security spend. We see that the allocation of budgets assigned to cloud security is like 1/3 to 1/5 the allocation of budgets normally assigned in the IT budget to security in the broader scope. So it's something that really, there's either an underestimation of exposure and also what is needed to protect our organizations. Some of the key slides that were shared in the keynote yesterday, so saying that, hey, we got to look at the app itself, its logic, the workload, as well as the infrastructure components that it runs on, and then apply security in each of these phases in our application development. So to do this, we're expanding the capabilities of Panoptica, the ones that I've already showed you for cloud workload protection, for API security, and container security, etc. And then we're combining them with the best of the features and functions and technology that Lightspin is bringing to the table. And so in the next couple of months, we'll be releasing a combined platform with these capabilities. I want to highlight in this session, just because I'm constrained on time, I'm going to highlight on the functionality that's new and I think really exciting and very powerful. So let me get right into that. So before I do, I'm just going to define a couple terms. So we're probably familiar with terms like attack path and surface and vector. I know you guys know all these things, but maybe if some in the extended audience may not have that same awareness and vulnerability. Actually, I'll come back to those. Let's look at these one at a time. So first threat, everybody went nuts when Log4j hit the fan. It just, it made headline after headline, and some of the experts are even saying we're going to have residual Log4j effects for the next 10 years. It was that pervasive. It was that, there were so many ways to exploit it, and it was just everywhere. So then when we see these things in the news, then the administrators and the ops, DevOps or SecOps people come in and say, well, okay, well, where is it in my environment? That was the first thing they needed to know. How exposed am I? And where is this exposure? How can I identify it? And then what do I need to do to remediate? But Log4j is not a one-time event. We see software vulnerabilities, critical vulnerabilities being announced all the time. It's an ongoing problem. And not only individual vulnerabilities, but even compromised software supply chains. And so if we're grabbing pieces of code that we trust in, and we feel are secure because of the source that we're getting it, and that source itself has been compromised, then that compromise extends to our environment once we incorporate it into our apps. So the first thing I'm going to demonstrate is how to find, and how serious is the problem? See that 78% of attacks exploit software vulnerabilities that are embedded either in the open source or in internally developed code, etc. They exploit some software vulnerabilities. It's typically the first step in an attack path kill chain. So let's say that I'm going to, I come in, I just see that there's been a new headline of some new vulnerability. Now my first question again, where am I exposed to this? Well, like any other CNAPP platform, I can scan my CI/CD images and I can look at those images in turn for all the different vulnerabilities that they include. But something that I really like about Lightspin, excuse me, is that the underlying technology is a graph database, which makes correlations, queries, and all of the information to be manipulated very, very efficiently and very effectively. And one of the things this enables in this specific case is the ease of querying all my assets for very specific things, such as software bill of materials component. So here I'm going to create a query here that says, okay, look at all my compute assets, and I'm going to add the criteria to look at the software bill of materials, package names, and I'm going to look for a very specific package name. It could be anything, but since we started with log4j, let me just punch that in. And type that in, 4j. And then any log4j component, and I can search for it. And then I see not only what's going to come up are all the images and workloads that have that software within their stack, but then I can also, with a simple click, see what the blast radius of exposure is, because what are those workloads connected to? So I not only see where the original vulnerability is, but also then where it can extend to via the connections that are already provisioned and in place and permitted. And so I can get a sense of that very quickly and very easily. Another type of concern, as we already mentioned, is in the area of misconfigured infrastructure. We've probably seen some of these attacks in the news as well. One of the popular ones, or one of the, I should say, famous/infamous, whatever, how you want to spin that, ones was when Tesla their clusters were hijacked for crypto mining. And the reason for this is because they left the Kubernetes API server publicly exposed. And then they were able to hack that and get in. And as they were looking around, they saw that there was even some secrets, key pairs of secrets in the resources that were in that cluster. And this is a common thing that happens. About 36% of the time we see that this happens in these environments, because software developers, yes, there are tools that can manage your secrets, but they're working so fast. They're like, for now, I just want to test it. I'll enter these credentials. I'm going to clean them up later. And they may not always remember to. And when you're looking in like thousands and thousands of lines of codes and configurations and YAML files, it's very easy to miss. And so when they know what they're looking for, they find them, and now they're able to extend their damage and say, oh, I can log in with these credentials, and now I can launch my own scripts and hijack this cluster. And not only that, but they were able to actually access data from S3 buckets within that cluster, which included some of their R&D data. So you can see this steps of attack. They find something that's publicly exposable, they find some keys, and then they continue to expand their foothold within that overall compute environment. Or for instance, last year, this was one of the biggest breaches that hit the news. It was a Pegasus Airlines breach. Maybe some of you guys heard of this one. Basically, there is a publicly facing S3 bucket that was able to be hacked because you're just brute force. And then everything you need to run an airline, from flight plans, navigation charts, all the procedures, even secrets about that plain text passwords and secrets and sensitive files that allows you to understand how their software runs, and 1.6 million files of PII. Every employee, their photos, their addresses, all this information was then leaked. It was like over 23 million files were leaked accordingly. So again, you wake up, you read this headline, and you're like, oh my goodness, can that happen to me? What do I need to do to protect my environment? So going back into our tool, we can say, okay, look, let's take a look at our security posture. If we know exactly the type of security exposure that we're concerned about, we can be very specific about that. So for instance, let's say, oh, I just read about Pegasus. I saw that their exposure was from AWS. So very specifically, it was for an S3 bucket that was public facing. I can just look for that explicitly. Okay, that's pretty easy. And then, you know what? Look, I have the same thing in this environment. I have a publicly accessible S3 bucket. It elaborates on what the risk is. It identifies all the assets that fall into that category. And then also for remediation, I have not only all the steps to take, whether I do this remediation manually, or I can accelerate the remediation by being provided the CLI, and then I can copy all this and create a ticket and have all that information there, or I could just start addressing the problem. That's one way I can approach. I'm going to show two other ways. I can also even just type the name of the risk. So for instance, for Tesla, it was an API server. So I'd say, okay, a public-facing API server, let me just punch in API server, and then, yeah, look, I got the same thing in my environment. I got a public Elastic Kubernetes Service API server endpoint that's, again, publicly facing. Therefore, that's the control plane of that entire environment. And then I have what that risk is, and then the steps, both the manual steps to take and the CLI to remediate. Very quick, very efficient. Or I can just even, if I don't happen to know the specific function, and I just want to say, what kind of data exposures am I faced with? Or what kind of public exposures do I have in my environment? I can just click on those categories, and then I'll have everything listed. And so even if I don't know the specifics about, hey, what about S3 buckets, or maybe some other storage, or maybe some other type of public exposure, I don't have to go down an exhaustive list, but then they're all categorized that way.
How is the severity rated?
Yeah, that's a really good question, Zoe. So how is the severity rated? These are based on the MITRE dashboard and common vulnerability ratings. And so they're rated individually, the risks are according to those metrics. But then also what I'm going to show is not just the rating of a specific risk in isolation, but as part of an attack path, and then how we rate those as well. And it's a combination of those risks plus any newly created risks that may be significantly greater than some of the parts. Like the way I like to express it is that, we could have in our households under the sink, a series of chemicals for cleaning and this and that. And yes, individually, they might have some risk, like don't drink this, it's bad for you, or don't do that. But sometimes you can combine certain chemicals and now you could make an explosive. And that's a whole new risk entirely, but it's only when that combination is present. And so this is why what we're going to build to is not just how the risks are rated individually, but also then when they're combined and brought together into that type of attack path kill chain, how they can create an entirely new element of risk that individually we might not be apprised of or fully aware of. Does that answer your question, Zoe?
Yeah.
Awesome. So then how serious is the problem? People might think, oh, well, that's just a one-off, Tesla, okay, fine. Nobody really does that. Everybody's learned, right? No. 70% of organizations out there do have this, public Kubernetes APIs. Sometimes they may not even be aware of it, or maybe just, a lax practice not to tighten that down. Or S3 buckets like Pegasus Airlines. 72% have these publicly available as well. That's leakage waiting to happen. And 36% of organizations still have embedded secrets in their resource, in their YAML files. So once people get in, they start combing through these. Now they can reuse those and get in much further and then exploit them even further. For instance, one of the ways they do that is privilege escalations. Now here's a very important intermediate step. It's usually when they've somehow wedged their way in, and now they're going to look to provide even more gasoline to their fire, if you will. Look how easy this is to do. I go into Amazon, I create myself a user account, doesn't matter what it is. And I'll give myself a username. And then as far as permissions, I'll say, I'm going to just assign a single permission to this user. And the permission I'm going to assign is, allow me to put user policy. Okay, it seems benign. Then the next thing I do is say, okay, I'm going to create a policy that actually says for the actions that I can take, I'm going to designate a wildcard action, meaning I can take any action. But since I have the policy in place that says I'm allowed to put policy, I'm going to put that policy to my own user account. Now, instead of just having one action that I'm allowed to take, I've put the policy that allows all actions for this user to take. I've escalated that privilege, and now I got free reign. You might think, oh, okay, well, that's just look for that specific combination. Well, there are myriads and myriads of combinations of ways to escalate privileges. These are just about 24 or more examples, but there are so many user roles in these cloud providers. For instance, in Google Cloud, there's 3,000 different user roles and combinations of permissions, and it's very easy to find logical loopholes within those rules to find a way then of elevating that permission. And then how serious is that problem? Well, 80% of the time, it's an intermediate step. So again, once they got their foot in the door, that's one of the next things that they're looking to do. And then that allows them a lot more damage capabilities. So how can I look for this? Well, again, I'm going to come back to my, my tool and I'll say, hey, take a look at my security posture. I'm going to clear my current filters and I'm going to look for identity and access management and all the risks there. And then again, same type of thing here. I have a user with IAM permissions, but there's no multi-factor authentication. Okay, pretty straightforward, but at least it's flagged. And again, I have all the steps to address that and also the CLIs to do that, or in this case, no CLI. Or I see that there's some permissions that have wildcards associated with it. And this is also very dangerous because, again, that kind of ability is very easy to exploit. So identifying what those potential loopholes are, plugging them early rather than letting them be exploited by attackers, it's very critical to do. Then the next and last thing that I'd like to show is the area of complex attacks. As I mentioned, these attacks are not typically just looking and exposing one vulnerability, but rather, because I know a lot of you guys are Star Wars fans, as am I, I'm going to use some Star Wars analogies here. So a system boundary is basically all the perimeter of a system. Think of the shield around the Death Star in Return of the Jedi, including the shield generator down on the planet. All points of the perimeter, the extent, the boundaries of your system are your attack surface. Any one of those could be exploited.
Point of failure.
Exactly. And then the attack vector is a combination of the doorway used and how it's been opened. So returning to this example, it's not only the shield generator bunker, but it happens to be the back door of the bunker, if you remember. And then how it was ultimately opened was via deception. It was opened from the inside, right? And so that then would be the specific attack vector that was used in this case. And then finally, attack path is the vector plus what can be done once inside. And this could then be anything from moderate damage to catastrophic damage. And so this is what we mean by attack paths. And then in the context then of applications, this is where I think Lightstream really shines, because it only takes about 3 steps on average to reach crown jewels. And we've already discussed 3 of those key steps. The first one was exploiting a software vulnerability. The second one was elevating privileges. And then once you have that, you have access, to many of these assets. So only 3 steps is needed on average. However, that's not to say that these attacks are only 3 steps. Some of them are wildly complex. And we are also developing in our Whisper Suites, you'll see some live demos of some exceptionally complex attack paths being analyzed. But this is what I really love about this tool, and I think it's one of its best features, is that you can have so much noise in your individual vulnerabilities and threats. Here's your software vulnerabilities, here's your privilege escalation vulnerabilities, here's your misconfiguration vulnerabilities, and you're just going to be buried in alerts and buried in reports. Whereas it contextualizes all of this information, combines them, recognizes that, hey, this exploit coupled with that misconfiguration and this elevation opportunity, that's a really lethal explosive combination. And so I can see not only the paths and the original vectors, but then also the criticality of them. And then I can double click on any of them and see the combination of exploits that lead then to the ultimate attack. So let me just pull one of these up, or a few of these up. I see I have network exposure on that particular resource, and then I have a workload at risk. And let me see. Oh, here's a good one. Exactly on point that what we're talking about. And we have a public workload that's exploitable, and it's got a CVE, a little bit slow network response, but it's going to come up. There we go. We got network exposure to this asset. We have a workload that has a software vulnerability. And then we also have some identity assets that can lead to that privilege escalation and then we're toast. But showing the connection, putting all of these threats into a single narrative within context to really allow us to become very apparent what it is that we have to run after the first and most urgently in order to protect that environment.
Does it also consider like difficulty level of resolving?
The difficulty level of resolving? No, it does just present you the remediations for resolution. Sometimes you can use the CLI, which will accelerate that, but you could also have the manual steps, but that's not really taken into consideration. It's more ranked along the lines of what could cause the most damage to your overall application. But yeah, a really good question. Then just to summarize before I'm out of time completely, so there's a number of requirements for a cloud-native application protection to really make it effective. We got to look at tools that help the developers make security-conscious decisions in the software selection, in the APIs and how they're coded. We demonstrated that when we talked about Panoptica, or even somewhere in between development and deployment when we're using infrastructure as code. Also, that has to be secured and hardened as well as the overall deployment infrastructure, which includes the Kubernetes posture, includes the cloud provider posture, includes all your roles and entity and entitlements to prevent privilege escalations. And then finally, your runtime environments to make sure that, okay, whatever is happening in real time in those workloads, there's not an active exploit either within the workload and the API communications and serverless functions, whatever it may be. And then finally, I think one of the most powerful tools is that attack path analysis to connect those dots and then to holistically see the threat to your application, your cloud-native application. So finally, I'm going to show that we have a lot of learning in this area. We have a new session track as of last year, the Emerging Technologies and Incubation track. And then within that, we have a learning map just on cloud-native security. And so a lot of offering there. And then we also want people to start using Panoptica. We're making this available for free. We want people to really just, test drive it, gain, familiarity, gain adoption, traction with it. It's free, no feature limits, no time limits. The only limit is scale, 15 nodes in a single cluster. If you need more than that, we'll figure out all those, we have those pricing and licenses, etc. But long story short, we want people to start using Panoptica. So